Hello everyone. In our previous session, we were discussing about predefined functions which are available already with the TSQL. They are part of here system functions. We have like aggregate functions, configuration functions, cursor functions, datetime functions. Aggregate functions are those like maximum, minimum, then sum, then variance, count. These are aggregate functions. On group of data normally these work. Okay, on group of data we should use them. Maximum must be a group of data, minimum also from group data we need to get, sum also we do with the group data. Okay, so like this we have few functions related to aggregation. These are aggregate functions. Similarly, we have seen few configuration functions like server name, service name, then version, language. We have seen these. These are related to SQL Server configuration. All these are predefined. These are system variables except connection property. Connection property is a function, but these are system variables. We know how to create local variables. Similar to them, we have predefined variables called as system variables. You can use system variables also. They can give actually system information and configuration information. Now cursor functions. We discuss about them as we progress more and more. Date and time functions. We saw all these. How to use date add function, date diff function, date name, date part, day, get date. Okay. Similarly, we have seen mathematical functions like floor function. Okay. Similarly, rand function. SQRT function, square function. These we have seen how they are working. I have demonstrated that to you. Then apart from these things, we have one more set of functions called as string functions. So these we use very much. Mathematical functions, date and time functions, and string functions, and sometimes we use even other functions also, like is null, is numeric, okay, then ident seed, ident current. So these also sometimes we use current user. These we are going to use sometimes, okay, but not every time. Sometimes we can use them. Whereas the mathematical functions, then similarly datetime functions and string functions, we use them very much. Okay, you can use them in the SQL queries. You can use them even within the procedures. The functions can be used as part of the SQL statement. When you write SQL statement, inside the SQL statement you can embed these functions if needed. Okay, but when you take a procedure, with procedures you cannot do anything like that. Here you can see few predefined procedures. You have system procedures here, stored procedures are available. Here you can find system stored procedures. When it expands, you can see what are the procedures available for us here in this. Okay, it's going to expand system procedures. You have so many procedures here. You can use them when they are needed. When they are needed, you can use them. So one such important procedure is sp underscore help. We use sp underscore help. With the help of that, we can actually here we can actually get the master data of the given page, given database you can find. Now just go to a query analyzer window, open the window. After that, using use command, open the database. I am working right now with the first DB, therefore I open first DB, select and execute. Okay, now let me show you. It is exec. To execute procedures, we need to use execute command followed by sp underscore help. Just execute this now. What do we get see in this? It is showing here all the system objects. Whatever system objects are available, you get them. Here you are getting all the system objects here. Okay, user tables, it's defining procedures. Similarly, it's showing primary keys. Okay, keys also are shown here. So different system objects are here returned. I think it's as good as getting actual using sys objects. Select star from sys objects. Okay, let us try to write here. What do we get? C. Sys objects we use. So what we get? C from this. It is showing in a different manner, but here sp underscore help is going to be totally different. So these are not same. This is giving actually overall information of the given database. Okay, it's showing you the database. It is showing about 2004 rows. Number of rows returned are here 2004. That many rows are actually getting returned. Okay, so here we have sys objects. Using this, what happens? It's going to show here again different types of objects here. Different types of objects like S we have here. Then similarly we have a U, user defined table, PK is primary key, C is constraint. So like this it's going to show few system objects. Okay, so with the help of the here exec sp underscore help, it is going to show metadata related to our database. Now after opening database here, I just want to find out here sp underscore help followed by take a table. Table is here tbl user. So user details are going to be getting displayed with this. So what are the columns we have in this? What are the keys are available in this? We find with the tbl user here sp underscore help. This can give information related to this particular object here. So this object information we are getting from this. So this is exactly what tbl user is a table name. In this, what are the primary keys, what are what primary key it is, then what are the other keys available here. So when you have text, what kind of collation it's using, all that information we get with the help of the tbl user. In the bottom you can see it, at what time it got created, then who is the owner of that, what type of data it's using, all we can get with the help of here sp underscore help. So using sp underscore help followed by tbl user, we are getting all that information. We are getting all that information using that particular command. Command is what exactly? exec sp underscore help followed by tbl user. Okay, so here this is the command. With the help of that we are executing it. We are finding out all that information. Okay, this is called as here a procedure. A procedure can be executed using exec followed by procedure name, and other thing is what you need to specify parameter. It's taking here a varchar type of data as parameter. Varchar type of data we need to specify in single quotes always. So this is what exactly, it's a procedure we are invoking. So procedures are also nothing but they are code blocks which are already defined for us. Small code blocks we write, they can be either procedures or they can be functions. All these are predefined. We are not defining any of them. We are using just predefined ones. Okay, whenever the Microsoft is making this SQL Server database, at that time it creates for us few helper procedures as well as helper functions. Those we are going to use. If those are not available, it's very difficult for us to find out few information. So with functions and with procedures, it becomes very easy for us. So like that we have there predefined here procedures as well as functions. We too can define procedures and functions. Okay, functions can be used as part of the SQL query, whereas procedures cannot be used as part of the SQL query. For example, we have a tbl user. So as far as tbl user is concerned, we have user ID, username, DOB, gender, password, DOJ. I want to get actually latest, in recent times who joined last, that person's record I would like to retrieve. Therefore, I can write like this: select followed by here I can use the max of DOJ. Okay, max of DOJ I can use here, max of DOJ followed by here username from TBL user. Okay, from TBL user I can use this way. Maximum date of joining I am going to get with this. Sorry, this is username. Okay, either the aggregate function or group by we don't have, therefore we cannot get. Just use only here select max doj from TBL user. It's giving here null value. Okay, here it is. Okay, select followed by what is the table structure we have. Let me expand and show you what data I can use from this TBL user. If you expand, the columns are here DOB, gender, password, DOJ. This is like this we have here. Sometimes it is accepting even null value. So username, this is DOB date time, then gender we have. So similarly password. Okay, so I would like to show you some function here. The function here, the username must be converted to uppercase, like that I try to show you. Here my focus is on how to use the function with the given select query. Username, then DOB, and other thing is here gender from TBL user. From that I would like to retrieve it. So select it like this, then execute. Now here we get the username, DOB and gender, but I want to show this in the uppercase alphabet. I want to show this in the uppercase alphabet, therefore I just change this query to upper. We have a function called as upper. With the help of that we convert everything into uppercase. So what we do, we are using the function inside the select query here. In the select query we are using the upper function. With that we convert everything into uppercase. Before we use upper, the Q and L were in the lower case, but when you use here upper, it's getting converted to uppercase. So like these functions you can use part of the select statement. Okay, so these functions and procedures even we can use in our code blocks or in our other procedures. You may write your own procedure, there you can be using these functions as well as other procedures. So we have started exploring how to write programs in the TSQL. So in our last session I think we have randomly picking some number, whether that number is a even number or odd number we found out. Similarly, whether the candidate is eligible for voting or not, we picked a random number, with that we tried. So there we were using if condition. Fine, we were using at the time if condition. Today once again I am going to demonstrate one more program. So there I want to use an if condition. Using if condition I would like to find out here whether the given number whether the given number is a perfect square or not. I'm not going to do anything other than that. That is a perfect square or not, I want to find out. So therefore here we take this way. Now here what I do exactly is I declare a variable, declare @num int, this equal to, here I don't assume anything, I don't assign any value, just leave like that. I am going to assign like that. Then here declare @sqrt followed by here sqrt, then here I write this one as float. Similarly declare @isqrt as int. I use like these three variables I am declaring here. Now first of all I should be assigning some number. I should assign a number right here. Using set keyword you can assign a number. @num is equal to, I use a rand function here. I can use rand function multiplied with here say some 10,000. Somewhat bigger number I would like to take, here. But when you take rand, this is going to return for us a float value. When you multiply with 10,000, what will happen? You are going to get some value. You are going to get some value. I mean, like this is going to be 9,999 dot. I mean, some xxx. That's uppercase range, and the minimum is going to be something like 0.00, something like that. That is going to be range. So 0 to 9,999. It can pick any number there. Now here, whatever we get, we should convert into integer. So therefore, put here convert function. Here you write what type of data we have to convert here. Int we take, then integer type of data it is. Then at the end you close this. Like this we can convert the given number, whatever is coming into integer, and assign to here number. So in the number we are assigning. Now next thing is we need to find out here square root. Okay, here write set @sqrt, this equal to, here find out now sqrt, followed by here what value we take here, @num, we take this one, we get like this. Next thing is what we need to take from that sqrt only integral part. Okay, therefore once again write here set @isqrt, this equal to, here convert, we put like this, we use convert here, then int, and here @sqrt, like this we use. So what we do, we retrieve both the sqrt, and again from sqrt we take only integral part. So when can we say the given number is a perfect square? Whenever the sqrt minus isqrt is 0, in such cases it's perfect square, otherwise it's not a perfect square. Like that we need to print here. Now use if condition, if @sqrt minus, this is @isqrt, if it is greater than, if it is equal to 0, then in such cases print, we use like this print. Okay, print here, here write, this is convert, we need to convert into string, followed by varchar. Then here write what we write here, here we write @num. Okay, then we put plus is a perfect square, like this we put. Else we just write here this is not a perfect square, copy this and here take it and print not a, sorry, it's not a perfect square, like this we print. So this is the code block we have written. This is called as anonymous code block. It does not have any name, so for ad hoc purpose we use it. Select this and execute now. So when we execute it, the picked up number can be shown as either perfect square or not perfect square. Just check for syntax, after that execute it. 9981 is not a perfect square, it is saying. Okay, once again execute. It says 4176 is not a perfect square. So 9144 is not a perfect square, it is saying. 616014 is not a perfect square, it is saying. 3162 is not a perfect square. So always we are getting it as not perfect square. So why it is so? I mean, is there any logic problem? 276, it's not a perfect square, it says. Okay, it says 225 is a perfect square, it is very much correct because 15 15s. So logically it's correct only. Logically it's correct. Okay, so it is logically correct only, therefore the code is working because it was picking 225 for us. At that time 225 is a perfect square because 15 15s we get actually 15 without having any fractional part we get, therefore 15 can be a perfect square root. 15 when you multiply with 15 you get 225, therefore the number 225 is a perfect square. And in this code block we are using functions. What functions we use? First thing is sqrt function, then similarly we use the convert function. Using convert function we can convert data from one format to another format. We can convert from one format to another format. So data must be compatible. For example, you are trying to convert a string data into integer. If the string if the string is containing digits, there is no problem. But if it's containing alphabets, it fails there. So it's wrong actually. In such cases, that's going to be wrong. So therefore, whatever you are trying to convert should be compatible data. In the form, in the string form, if you have any number, so in the single quote you put some 1, 2, 3, 4, that can be converted to integer. But when you have some A, B, C, D, you cannot convert. So therefore, compatible types can be converted from one form to another form. So therefore, using convert, we could convert the string, the random value. It's going to give us a value between 0 and 1. When you multiply the value which you get between 0 and 1 with the 10,000, you get a number. It may be, the range for that is going to be 0.xxxx to so 9999.xxx, like that. That is going to be the range for the number which is here getting created for us. So when you multiply with 10,000, that is the number you are going to get. It's going to be in that range. So from that we are converting it into integer. Therefore, after decimal point, whatever digits are there, they get truncated. Only integral part you get. Now after that, what we do? We find out square root of the given number. Given number square root we find out. So when we get square root, for example, you take 220. In the case of 220, you get 14 point something. Okay. Similarly, when you take 200, you get actually 14.12 something like that. So therefore, but when you take 225, you get it as perfect 15. So such things are called as perfect squares. Therefore, here whenever you have the difference between the here what we do, at the rate sqrt at the rate num, with that what happens here, you can get square root. Square root may contain after decimal point some digits. They may not be 0, 0, they can be something else depending on the number the computer is picking there. After that, what we do, set at the rate isqrt equal to convert int at the rate sqrt. So from the sqrt we are taking only integral part. Okay, we are taking integral part. Suppose the program is picking 225 its number. So in such cases what happens, sqrt contains 15.00, then isqrt is going to contain 15. So therefore, whenever you divide isqrt from sqrt, the value is going to be 0. Therefore, it prints it as perfect square. Otherwise, it prints it as not a perfect square. So like this, the program is going to be working for us. The program is working in that manner. In that manner, the program is working. So I am using internally here these functions. These functions I am using. Remember that TSQL is not a full-fledged programming language. For writing small functions, procedures, triggers, we use them. So for writing very small functions, for writing small triggers, and for writing small procedures, we use the TSQL, code blocks. So this is what exactly, it's an anonymous code block. In this code block, I am using predefined functions. Similarly, I am declaring few variables. At the rate num is called as a variable. What type of variable this is? Integer variable. Okay. Similarly, sqrt is a floating point type of data. isqrt is integer data. So using set command, I am assigning value to the num. Okay. Similarly, using set, I am assigning to sqrt at the rate sqrt, and with the help of set again at the rate isqrt, I am assigning some value. So like this, you can use assignment statements. This is nothing but here a sequential flow of code up to this if condition. Up to this if condition, it's sequential. But from here, what is happening? It is actually getting branched off. It's getting branched off. Here, what you have taken at the rate sqrt minus at the rate isqrt equal to 0. In such cases, we print it as a perfect square. Otherwise, it's not a perfect square. Like that, we are trying to print. So this is a program with which we find out whether the given number is a perfect square or not. Like this, we do it. Once again, let me execute and show you. Okay. Now next thing is, sometimes you need to go with iterations. Iterations you need to do. Repeatedly you have to execute same piece of code. For that, in the TSQL, we have a loop called as while loop. So using while loop, you can iterate over the statements. So same statements can be getting executed repeatedly with the help of while loop. You can use a while loop. With the help of while loop, you can iterate there. So let us use actually a while loop to print all the ASCII characters. To print all ASCII characters, we use the while loop. So using while, we are going to here print all the ASCII characters. So let us use here all the ASCII characters. Let us print all the ASCII characters with the help of say print statement here. Using print we do now. So here I put a comment. Following code block uses a while loop to print printable ASCII characters. It's going to print all the printable ASCII characters. Therefore, we write here code. First thing is declare at ch, nothing but character. I put it as tiny int. I can declare this as tiny int. I use a value 32 like this. I am going to use this as 32 here. I am going to use this one as 32. So here I write a while loop, while @ch, okay, less than 255. I want to print this. I want to print here. So here declare @ch tiny int equal to 32. Then here while @ch less than 255. So from 32 to, instead of using up to 255, let us try to print. So here right now print. What exactly I want to print here? I want to print in the form of character, char. Then here write @ch. Okay, I want to convert to character. Then I want to print it. Before that, I try to use like this char, followed by here /b I use. Okay, then plus here chr @ch. I want to concatenate and I want to show there. So here on top of this one here, first I put print char of it is 32. I want to print a space. After printing space, I would like to do with this. So here this way I want to print some character. Use here /b. With the help of that I can come back. It's nothing but backspace, or else I can put here 8. 8 is equal to backspace. Now followed by here write set @ch equal to @ch plus 1. So I want to increment this. Once that is completed, I want to increment it. So in the while loop, whenever you have more than one statement, not only with while, even with if condition, we should use a beginning of block, and at the end of this you should use here end. Like this you should write here the beginning of the block and ending of the block. So what we do here, we declared a ch tiny int. We are printing the space followed by while @ch less than 255. We are beginning and coming to end, and we print here 8 backspace. We are going to print here followed by character. So with this now, how the result comes, let us see. So here select this and execute. Check for the syntax, execute this. Okay, so every time you use here the char8, it's printing like this. It should not be getting printed that way. Therefore, remove this. You can remove this. We'll try to print this one here. So let us try to print it. Now execute once again. Select this code block and execute. So when you execute, it's going to be showing this way here. It's going to be getting displayed like this. Suppose you don't want to show vertically like this, you can attach everything to certain string. Then after that, at one time only you can display it. At one time you can display. So therefore here declare one more variable. On the top you declare okay, declare sentence, or chars you put here chars. This is varchar. How much length we would like to take here? Up to 255. Let us take this equal to empty. We assign like this. We are assigning in this some empty string there. So every time instead of printing here, we just concatenate it. Let us try to concatenate. Right here @chars set we need to use here. Set @chars equal to not that. So set @chars equal to, here we write this one as @chars plus followed by here we try to write like char at the rate ch. So character we are printing at the rate ch is containing initially 32. That means with space we start, then followed by all the characters one by one up to 255 we take it. 255th character is not going to be displayed here in this. Now at the end of this we print now the chars, print at the rate chars, like this we write. So with this what happens, one character we are picking, then concatenating it to chars, at the end we are printing it. Just execute this. Okay, this is wrong thing actually we have done. Now execute. It's printing like this. You can see all of them are coming in the same line. You get all of them in the same line. We are getting everything in the same line. Okay, suppose if you want to separate, once it reaches actually 127 into next line, you can separate it. You can separate actually in such cases. Here see, if condition we use, if at the rate ch equal to say some 127 or 128, in such cases you can separate it. So here write set at the rate chars equal to, here write at the rate chars, then plus here try to specify this one as here a new line character, let us embed. We just try to put here a new line character like this also we can specify here. I am trying to put a new line character in that slash n. When I say it's a new line character, I want to put a new line character there. Then once again try to execute this. It is actually printing slash n, so slash n should not be printed for us. So therefore to get slash n, here we write like this char followed by this is 13 we put. 13 we put, or else we put here 10. So 10 we put, line feed we put. So using line feed we try to put into next line. We try to put into next line whenever it is meeting that condition. Execute this. Now here in such cases it is actually moving into next line. You can see after this it is moving into next line. So like this we are printing all the characters, all the ASCII characters in this. And so after 127, when it's 128, it's moving into next line. It's moving into next line. So like this we are printing characters here. We are printing characters. First set is called as ASCII normal standard ASCII characters. Second one is going to be extended ASCII characters or basic character set from 32 to 127. From 127 to 255 is called as extended character set, because you find in this many different characters. Many characters we use, probably we don't use them in English. Here these are used with some other languages like Spanish or French language, or with some other languages it is used. So therefore this is called as here advanced character sets or extended character sets. Here you may have some graphic symbols also inside this. Some graphic symbols also you can find inside this. So this is called as here extended character set from 128 to 255. That's called as extended character set. So using while loop we are doing it. While at ch less than 255 we are beginning it. So we are repeatedly executing it. How long that is? As long as ch value is less than 255. But once ch value becomes 255, you come out from that. You are going to be coming out from that. So like this we are using here while loop. We can use a while loop like this. And yesterday, in our last session, we have done a program to find out whether the given string is a palindrome or not, in which we were using a reverse function. So using reverse function, we were reversing the original string, then we compare reversed and the original string. When if both of them are matching, in such cases, it's a palindrome, otherwise not a palindrome. Okay, similarly now here what we have done, we have created a while loop. With the help of that we are printing all the ASCII characters. Okay, now next thing it's going to be here finding out whether the given number is a square root or not. Sorry, whether the given number is a prime number or not, we need to find out. We need to find out whether the given number is a prime number or not. So prime numbers are those, I mean, who have only 1 and the number as factors. They do not have any other factors. Apart from 1 and the number, you don't have any other factors. Such numbers are called as prime numbers. So computer should pick a number. So that number, whether it's prime or not, we need to find out using the code. Here now, see that following code block finds whether given number is a prime number or not, is a prime or not. Okay, it's going to find out whether the given number is a prime number or not. We need to find out whether the given number is a prime or not. Here write, here declare at the rate num. This is again int. We need to assign a value to this now. Declare at the rate num int. Okay, already we declared, therefore it gives error because on the top we declared in the same window. Due to that, it's showing like error. But no problem, while executing you don't have any difficulty in that. Similarly, here write set at the rate num. Here this equal to, okay, similarly declare at the rate fact, followed by here, I mean at the rate fact, this is going to be again int. Here we use like this. Here declare at the rate fact found as bit. Here this is equal to, we set 0. This way we specify here. Declare at the rate fact, this is found, fact found, we take bit as bit equal to 0 there. Okay, so it should be picking a number. It should pick a number which should be, I mean, greater than, it should be greater than or equal to 1. Like that we need to get a number here. So greater than or equal to, I mean 2, we need to get 1. There is no point in finding like that with 1. Now write here set at the rate num, this is equal to here. Let us take in this rand function. Once again we use here multiplied with up to 1000 we take. From that the given number is a prime or not, we can find out. And here we convert this into integer. Convert followed by int here into integer, we convert it. Then whatever number we get, this can be from 0 to 9999. So therefore put here plus 2. So in such cases you can take a value from 999, so it's going to give you 10,000, 1001, up to 1001 it can take now. 2 to 1001 it is. It's going to be 2 to 1001, that is going to be the range for this number here. Okay, so here this is going to be, it's going to pick a number, then after that it's going to be taking only integral part. It will not take actually fractional part. Now next thing is what we need to check. Here write set at fact, here write set at fact equal to 2. We set this as here 2. At least with 2 we start in this. Here write while loop we use, while at fact we write here less than or equal to sqrt of the given number. What is the number exactly? At the rate num. As long as it's less than at the rate num, we need to do this. So go with begin then end. But see, as long as the loop is getting executed here, what is happening? Every time the sqrt function will be called, which is meaningless. So therefore declare here one more variable. Declare, we write here, this is sqrt, at the rate symbol we have to use here. Then this is float, like this we can do it. This is going to be float data. Float data, that's going to be here right now set at sqrt equal to here. This one is, we need to find out square root sqrt of at the rate number. Like this we take it. We are going to take that way. Now here this sqrt you use in the place of calling this function. Every time calling function is really time wasting process. So every time the function has to be called, that's going to burden on the database. Okay, so therefore here while at the rate fact less than or equal to sqrt, we try to do this. Now here we try to print if condition we use. If here at the rate num followed by percent at the rate fact equal to 0, so in such cases we have used while, okay, but here we require a begin and end. Begin is required after the immediately after the while we need to put. Okay, so this way we are going to keep it. Here write if at the rate num percent at the rate fact equal to 0. In such cases again we use here begin, then once again we put here this one as end. So what should happen in such cases? Whenever they are matching, whenever that is meeting the condition, now in such cases we need to set first of all set at the rate fact found at the rate fact found equal to fact found we need to take here fact found equal to, we put this as 1. Similarly we go with the break. You can use here break. With the help of that you can break this loop and come out from that. From the loop we are going to be coming out. Now after this end, here we need to write set at the rate fact equal to at the rate fact plus 1. We use like this. This way this can be incremented by 1. We are going to be incrementing it. Okay, so by 1 we are going to be incrementing. Now here you can print exactly what happens. Use if condition once again. If at the rate fact found equal to 1, in such cases print, you need to convert the given number. Convert, here it is varchar followed by at num plus, here it is not a prime number. We print this way it as not a prime number, else we go to this, then we try to print it as prime number. Here it is a prime number, we print, may say this as a prime number. So like this we are trying to write the code. Okay, so this is going to be finding out whether the given number is a prime number or not. So what we have done in this C, we declared a number at the rate num integer, at the rate fact this is also integer, at the rate fact found bit I am going to take this as 0, with 0 I am initializing. So with this what happens, I mean as long as the factorial is not factor is not found, it is going to be having 0 value. But whenever the given number is divisible by fact exactly, in such cases that is what, it's not a prime number, because you have factors there. Based on that logic we try to do. So here what I have written, declare at the rate fact found bit equal to 0, declare at the rate sqrt float it is. Set here at the rate num equal to convert int rand multiplied with 1000 plus 2. So it can take a value from 2 to 1001. The possibility is that the range is going to be 2 to 1001. Then here set at the rate fact equal to 2. I want to start from second number. How long I want to continue? Up to square root, up to square root of that number I want to here divide that. Up to sqrt I want to divide that. So therefore here I am finding out here square root of the number. Then here we write while at the rate fact less than or equal to at the rate sqrt, begin it. Then if the number exactly is divisible by at the rate fact, that means the remainder is going to be 0. Therefore what we need to do, we need to set at fact found equal to 1, then break it. So with break what happens exactly, we come out from the while loop. So this is called as forward jumping. So from the current loop, from the while loop, we jump out and come to this part of the code. Up to this part of code we are going to reach. So like this here, the if condition is going to be working. If at the rate num percent at the rate fact equal to 0, therefore what we do, we begin like this, then set at the rate fact found equal to 1, then we break it. Suppose this is wrong, nothing will happen there, always the fact will be getting incremented. How long we continue? As long as at the rate fact is less than or equal to at the rate sqrt. So like this loop is going to be working for us. Now here execute this piece of code. Now let us execute. First of all, check for syntax. There here is not okay. Convert. I should use convert here also. I should use convert here. I am using there also convert function. So using convert, now we can do it. So select it and here check the syntax, execute it. 710 not a prime number. That's absolutely correct, because 710 exactly divisible by 2 for us. Now 898 not a prime number, because 8 is nothing but here even number, therefore we cannot say that as a prime number. Even 93 is not a prime number, because 93 can be divided by 3. 999 cannot be definitely a prime number. Okay, 434 also cannot be a prime number. Now 280 cannot be a prime number. 751 a prime number, it's saying here. 751 is a prime number because it cannot have any other factors. Is it really so? 751 does not cannot I mean with 2 you cannot divide definitely. 7 plus 5 is 12 plus 1 13. So 13 also not divisible by anything. With 3 you cannot divide, with 9 also you cannot divide, with 2 and 3 you cannot divide, therefore with 6 it's not divisible. With 11 can you divide? 11 6, with 11 also you cannot divide. With 13 is it possible? 13 5s are how much? 65. So 13 5s are 65. Therefore how much you get? 101 you get. So definitely it's not possible. With 13 also you cannot divide. With 17 also you cannot divide. Therefore this is nothing but a prime number. 751 is a prime number. Once again execute, what you get? 89 a prime number, it says. Is 89 a prime number? You cannot divide this with any other number, with 2, with say 3, with 5, with 4, with 6, with 7. With 7 also you cannot divide, with 9 also you cannot divide. Okay, similarly if you take 11, with 11 also you cannot divide. Therefore 89 a prime number. Once again go with this. It says 776 not a prime number. True that is, because we have 6 ending digit there. So since the last digit is 6, this is going to be divided, this is going to be divisible by 2. So therefore it is not a prime number. It is not going to be a prime number. Like this, with the help of this while loop, we could find 801 cannot be a prime number, because 8 plus 0 is 8 plus 1 is 9. So the sum of the digits is 9, which is divisible by 3 exactly. Therefore it is divisible by here 3 exactly. 3 2s are 6 we get 2 0. 3 6 are 18. Again 2 you get 2 1. 3 7s are 21. So 2 then followed by 2 6 7 is the result for us. When you take 3, when you divide with that, it's going to be 267. Like this, we can divide the, we can say the 801 not a prime number. So like this, what is happening? It's actually finding out whether the given number is a prime number or not. So like this, we are using the while loop, and similarly if condition also we use. So like this, these you can use for real-time database programming, in retrieving data, in updating data. In some other cases also you can be using the if condition as well as while loop. As well as while loop and if condition you can use comfortably. So this is exactly a while loop. So using while loop here, I am iterating over the numbers. Factorial I am taking there, at the rate fact I take. So fact equal to 2 I take. How long I am going to continue? As long as the fact is less than or equal to the square root of the given number. So as long as it is less than or equal to the square root of the given number, I am going to iterate. Then with that what happens? I am going to here find out whether really the fact can divide the given number. If it is divisible by at the rate fact, in such cases we get the remainder as 0. So if the remainder is 0, that means what? It's not a factorial. It's not a prime number. So like that we are trying to calculate here. This is the code. With the help of that we could find whether the given number is a prime number or not. Whether it is a prime number or not, we can find. So this piece of code we have written here. So we have written a new code block. With the help of that I am finding out whether the given number is a prime number or not. So therefore we have written today 3 different programs. So in these programs we are using the functions, predefined functions we are using inside the program, and similarly we are using if condition. and one more thing is what while loop also we are using. We are using even while loop, if condition in these code blocks. Okay, so these are called as here anonymous code blocks. These are called as anonymous code blocks. Similar to them you can write, similar to this you can use these predefined functions, if condition, while loop within your procedures. Whatever procedure you are going to define, you can use them, inside your procedures, inside your functions, or whatever any other kind of code block if you write, you are going to put in those things. Sometimes you may write trigger, in the triggers also you can embed those, you can use if required. So therefore today I demonstrated to you the if condition, similarly while loop. Along with that I explained you exactly what are procedures, what are functions. This is giving you little idea on the TSQL. It's not completely, everything I did not give you so far. So I am just showing you the features of this TSQL. That means what are procedures, what are functions, what are DDL commands, what are DML commands, what are DCL commands. More we are going to do, in depth also we are going to do. But first of all I am showing you a tour of this. So how, things you can use in the